morning, everyone. I hope you're doing well. We're going to talk a little bit about the basics of static electricity today. And you're actually going to find that the basic of static electricity is very similar to some stuff we did in chemistry. So we are going to get into the notes on atomic structure, but on the top of page 3 in part A, if you haven't had a chance to write or draw anything that comes to mind when you hear the word static electricity, just hit pause on the video for a second and fill in the top of page 3 just above those terms that you did the other day. So just hit pause now. All right, so hopefully you had a chance to write or draw anything that comes to mind when you hear the word static electricity. And we're not obviously in class, so we can't kind of share our ideas together, but these are what some people have come up with in the past. So we've got some lightning here, right? You know, static on the TV, right? Or radio, rubbing a balloon on your hair and then sticking it to the wall, shuffling your socks along carpet and then maybe getting a shock if you touched a doorknob or something like that. And we're going to come back to that. Pulling a shirt out of the dryer and having a sock stuck to it, or just in general having your hair kind of stand up on end when you touch that Van de Graaff generator. So those are all great examples of static electricity. So we've got some elements from the periodic table here. And the little caption below says, perhaps one of you gentlemen would mind telling me just what it is outside the window that you find so attractive. So again, we're going to be looking at that kind of attractive force between different things and what causes and what makes that. So these are the outcomes that we're going to do. Today we're going to talk about that particle model of electricity, and tomorrow we'll talk about those early models of electricity. So basic atomic structure, again, we talked about all of this in chemistry. It should be a review, so quick day for you today. Gives you a chance to catch up on other subjects or catch up if you haven't had a chance to finish some of the assignments from astronomy and things like that. So basic atomic structure, matter is anything that can be touched physically. All matter is made up of atoms. Now remember, even things like air have particles that we can kind of physically touch. It has mass and volume would be the definition of matter. But all matter is made up of atoms, and atoms are so small that even the most powerful microscopes cannot see them. Atoms are made up of 3 main particles, so you should have we should be pretty quick at knowing what those 3 main particles are at this point in time. And if not, here's a review for you. So 3 main particles are our protons, electrons, and neutrons, right? So protons, if we follow this arrow, these are the positive charges. They're found in that dense center of the atom called the nucleus, and they're really heavy. We're going to pop down to the bottom. Neutrons. Neutrons are also found in the nucleus. They're also quite heavy, but they have no charge at all, or they're said to be neutral. And electrons are found orbiting the nucleus. Again, remember in chemistry we had 2 fit in the first shell, and then 8 in the second, and 8 in the third. And electrons have that negative charge. Now I've got a big giant star beside electrons because we're going to talk a lot, especially when we get into current electricity, about the movement of those particles. And our protons and our neutrons are stuck in the nucleus, so they can't move. So electricity is those moving electrons. Okay, so electricity deals with the electrons, if you can read that scroll that I have there. So again, just a quick refresher. Neutrons are in the nucleus. They have no electrical charge. Protons are in the nucleus and carry a positive charge. Electrons move around the nucleus and carry a negative charge. And we'll talk tomorrow about how we got those words, positive and negative. Okay, so again, remembering that electrons move around, not the protons. So electricity is those moving electrons. So if an object is negative, it has an excess of electrons. And excess means more. It has more electrons than, say, protons in the nucleus. And we'll talk a little bit about this tomorrow as well. If an object is positive, it has a deficiency, or it has less electrons than protons. And if an object is neutral, it has an equal number of electrons and protons. So when we talked about our atoms and we drew our Bohr models in chemistry, we always had an equal number of protons and electrons. So our atoms were always neutral, and by definition, atoms are always neutral. And that's why I said the number of electrons will equal the number of protons in grade 9 science only. And in grade 10, you talk about ions, which have either a positive or a negative charge. So just a friendly reminder, charge is conserved. It cannot be created or destroyed. So if we have less electrons than protons, it must have given that electron away. That electron isn't destroyed. It must be given away. So that's just a quick little refresher on the basic atomic structure that you need to know for the electricity unit. So once you finish filling in your notes on page 5, I do have a second video that I would show in class that I put in the folder. It's an extra one. It's up to you whether you choose to watch it or not, but there is an exit slip. So if you go into the assignments tab, click on assignments, and please do exit slip for today's date. It will be exit slip day 1. Thanks very much. Have a great day. Bye-bye.